I'm Rayesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
Imagine a submarine that doesn't rely on noisy propellers or bulky jet engines, but instead uses pure light to cut through the ocean at breathtaking speeds. Sounds like science fiction, right? Well, thanks to breakthroughs in fiber laser technology, this concept is edging closer to reality, and it could change naval warfare forever. At the heart of this futuristic propulsion system is a simple yet powerful idea. Fire ultra-short, high-intensity laser pulses into seawater, and you create plasma, an electrified, superheated state of matter. That plasma expands explosively, generating a detonation wave. And that wave, it produces thrust, pushing the submarine forward. In other words, light itself becomes the engine. But there's more. This process doesn't just create thrust, it also sparks one of the holy grails of underwater travel: supercavitation. That's when vapor bubbles form around the submarine, wrapping it in a cushion of gas that drastically reduces drag. Instead of fighting the crushing resistance of water, the submarine essentially rides inside its own bubble. The result is faster speeds, greater efficiency, and the tantalizing possibility of submarines that can travel at velocities we once thought impossible. Traditional propellers, even advanced pump jet systems, generate noise, suffer mechanical wear, and are limited by the physics of water resistance. Fiber laser propulsion eliminates those moving parts entirely. No propellers mean less noise, less maintenance, and much higher stealth, a huge advantage for military operations where silence is survival. Imagine submarines that glide almost undetectably, moving faster and deeper than ever before. The concept itself isn't brand new. Scientists in Japan first proposed laser propulsion underwater more than 20 years ago. The challenge, however, was direction. Plasma detonation waves expand in all directions, wasting energy and making it nearly impossible to generate useful forward thrust. Early experiments produced only tiny amounts of propulsion, nowhere near enough to move a vessel. That's where recent breakthroughs, especially in China, have reignited global interest. Researchers at Harbin Engineering University have managed to generate an astounding 70,000 newtons of thrust using just 2 megawatts of laser power, a figure comparable to a commercial jet engine. The trick: delivering high-energy laser pulses through ultra-thin optical fibers, thinner than a human hair, and then carefully channeling the expanding plasma using gun barrel-like devices at the fiber tips. Against expectations, this design actually improved efficiency by several orders of magnitude. And then there's the clever use of tiny spherical particles, or working media that get accelerated by the plasma wave. As these particles shoot out in one direction, they create equal and opposite thrust for the submarine. It's Newton's third law, but applied with lasers, plasma, and precision engineering. The implications are enormous. Submarines with fiber laser propulsion could move faster, quieter, and stealthier than any conventional vessel. They could evade sonar detection, travel greater distances with less energy, and even extend the range of underwater weapons like torpedoes and missiles through the same supercavitation principle. In theory, some experts even suggest this could one day allow underwater travel at speeds approaching or surpassing the speed of sound. Of course, challenges remain. High-energy lasers generate immense heat that must be managed. The delicate optical fibers must survive extreme pressures and corrosive seawater. And integrating such systems with the heavy, stealth-optimized hulls of nuclear submarines won't be easy. Directional control of the detonation waves also requires highly advanced feedback systems to ensure smooth, stable thrust. Yet, despite the obstacles, the trajectory is clear. Fiber laser-induced plasma propulsion could mark the beginning of a new era in underwater mobility. For navies, it offers speed, stealth, and strategic dominance. For science and exploration, it promises the ability to reach deeper and more remote parts of the ocean with greater efficiency. So, while today's submarines still rely on propellers and jets, tomorrow's might glide silently through the seas, powered by beams of light and wrapped in a bubble of plasma. It's not just propulsion, it's a revolution in how we think about moving beneath the waves. The age of laser-driven submarines may just be on the horizon.